In this lesson, you're going to learn how to find the coefficient of determination. I will say before getting into this video that it might be helpful to watch the video on the correlation coefficient first. The coefficient of determination, or R squared, shows how well the regression equation fits the data in the scatter plot. So R squared is always going to be in between 0 and 1. And I'll show you why it's 0 and 1 in just a second. 0 means that the line is not a good fit for the data. And 1 means that the line is a good fit for the data, and it is useful for making predictions about future observations. R squared measures, or determines, if you will, the goodness of fit of the linear regression equation. It does not measure the association between the two variables. So if you remember from the correlation coefficient lesson, the correlation coefficient R measures how closely related the variables are to each other. So correlation coefficient measures the closeness of a relationship. The coefficient of determination determines how well the line fits the data. And we do have a formula for finding R squared. I am not going to go through the formula in this video because it is a bit tedious. And I do have a video on finding R, which involved the data set with the study times versus the test score. We did this whole table. We added everything up, divided by n-1, and we found R. I'm going to give you a little shortcut. If you wanted to find R squared by hand, you can do this whole same process, exact same process. It's kind of a kill two birds with one stone type of thing. And then literally all you have to do is take this R value that you found, and R squared means that you are squaring that value that you already found. So that's the reason why I'm not going to step you through the process, because we've kind of already done the process and it does take a little while. And so when you square this value, you should get 0.49 for your coefficient of determination. So that's how you can do it by hand. If you need to do it by hand, you might go back and watch that video. Otherwise, you can use your calculator. We're going to go into the linear regression function of our calculator, of our stat options, basically. And remember that before you do this, you need to turn your diagnostics on. So you're going to go to your catalog, which is second 0. And then you're going to go down to D for diagnostics, turn them on. Once you turn them on, then you can input your data. I'm going to go over here. I've already input the data. It's the same data from the linear regression equation video, the correlation coefficient video, and now this one. So it's literally the same problem, just split up into 3 videos. So I'm going to go to Stat, Edit. You're going to input your data, which I've already done. And then I'm going to go second mode to go back to the home screen. Stat, Calc. This is still part of linear regression. So I'm going to go to linear regression. I think I've been choosing number 9. A number 5 would work too, but it doesn't matter. Second L1, comma, second L2, close it, enter, and you'll see the third, 1, 2, 3, fourth line says R squared. So R squared is about 0.49. which is what we found when we did it by hand. So you can see, hopefully that helps you be able to see where it comes from. When you do the actual formula with R, you just square that value, that gives you R squared, or you're just using the calculator. And I wanted to talk about, at the very beginning, I said it's always going to be between 0 and 1. if you think about squaring a value, when you square a value, it is always positive. So when we square negative 0.7, it's positive. When we square positive 0.7, it's positive. So any R value squared is going to put it into the positive values for R squared, which will always be between 0 and 1. If you think about it, back in the correlation coefficient video, R had to be between, -1 and 1. And then if we were to square this value, that will be 1, and square this value, that'll be 1. And then 0 would be in that interval. If we were to square 0, it would be 0. So that's why it's always going to be positive there. That's not a huge deal when we're talking about it, but I just want you to see kind of where that's coming from. R can be in the negative because it's not squared, and then R squared is always going to be in the positive, but they'll all be within the range, less than 1. All right, so does the regression equation appear to be a good fit? So remember that the closer to 1 it is, the better fit it is for the data. This is kind of in the middle. R squared has to be in between 0 and 1. 0.49 is pretty close to 0.5, which is pretty close to the middle. So I would say it is a 0.49 is a moderately good fit, because this value represents a percentage. So something up here, I think I actually skipped it on accident. This decimal value is the decimal representation of the percentage of variation in the observed values that can be explained by regression. So if I convert this to a percentage, then this means that 49% of the observed values, what was it? Yeah. And the response variable, which is the Y value, can be explained by the regression equation. So if we had gotten 1 for R squared, then that would be 100% of the observed values can be explained by regression. So it's just showing you a percentage. If we were to look at the scatter plot of this, I still have it in my calculator in the stat plot. I still have this data in there, and then in Y equals, I still have my regression equation in there. So I just pulled that up. You can see that we have our scatter plot and all the dots are kind of spread out, and then we have our line going through it. And this line is R squared of 0.49, which is saying that 49% of our dots are explained by this line. And basically it's measuring this error between the dot and the line. So this one here, it's kind of, I can't show you here, but actually, yeah. The dot that's the farthest from the line has the most error. Error is representing the distance of each observed value from the regression line. And we can see that there are a lot of dots, well, 49% of them, that are really close to the line. And those are the lines that are being, or those are the observed values that are being best explained by our linear regression, and thus R squared. So that's all I have for this lesson. Oh, wait, just kidding. I want to show you one more thing. Let's say, for example, that you were given R squared to start with, and you need to find r. Now we know that when we were given r, you just square it to find r squared. If we want to go backwards, we're going to use the inverse operation, which means that we are going to square root 0.49. And when you square root something squared, that undoes it. And there you go. The only thing that you don't see when you do this is the sign. It's supposed to be a negative, so be careful there. But that's kind of how you can go back and forth between the two without doing the whole formula. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help. See you in the next one.